This video is going to cover graphing quadratic functions, and we're going to do this using the pattern about the vertex method. So we're going to start with the most basic quadratic function that we have, which is y equals x squared. So to graph y equals x squared, we're going to start with the vertex. And the vertex here is 0, 0. I know that because there's nothing with my x here, and there's nothing behind my x here. It's going to start at 0, 0. There's no numbers putting it anywhere else. So we're going to start right there at the origin, which is 0, 0. Then I can make what's called a pattern about the vertex table. Since there's no number in front of my x here, my coefficient that I can't see is 1. And that's because 1 times anything doesn't do anything. So we would have a 1 in front, meaning that it doesn't affect the problem at all. So if I have a 1 for my coefficient, I only need 2 columns in my pattern about the vertex table. These columns are going to be labeled x and x squared. X is going to be the x movement of the graph, meaning your left and right movement of the graph, and x squared is going to be your y movement, right? Because y is x squared. So y movement means your vertical movement or up and down movement. So we're going to start with moving our graph left and right 1 from the vertex. So if I start right here at the vertex at my origin and I move to the left or right 1 square, my y values or my vertical movement is going to be x squared. So I take my value that I picked for my movement for x, so positive 1, and I square it. Positive 1 squared is 1. And the cool thing about this is we also have negative 1, and negative 1 squared is also 1. So they actually make the same movement each way, whether you're going to the left or the right 1 square. If I move to the left or the right 2 squares, I'm going to have to square that x movement to find my y movement. So 2 squared would be 4, as well as negative 2 squared would be 4. And that what I mean by that is 2 times 2 is 4, and negative 2 times negative 2 is also 4. So I would move up 4 squares because it's a positive number. If I move to the left or the right 3 squares, I would square positive or negative 3, and I'd be moving up 9 squares. So now that we have that table made, let's go ahead and start at our vertex and follow my pattern about the vertex or pattern around the vertex. So looking here, I'm going to move left or right 1 square and up 1 square. So the first one I'm going to do is to the right 1, up 1, and then go back to my vertex and go to the left 1, up 1. So left or right 1 square, up 1 square. Next is left or right 2 squares, up 4 squares. So from my vertex, I can go 2 squares to the right and up 1, 2, 3, 4 squares. From my vertex, I can go 2 squares to the left and up 1, 2, 3, 4. If yours doesn't look like mine, you may not be going off of your vertex. So the thing about this type of graphing is we don't go from our previous point. We go all the way back to our vertex and we graph from our vertex over. Okay. Last one is going to be left and right 3 squares from my vertex and up 9 squares from my vertex. So we're going to go to the right 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And to the left, 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. It should look like that. It will be a U shape, which is called a parabola. So whenever we're graphing quadratics, they should be U-shaped like this in a parabola form. Just as a side note, so you're aware, the axis of symmetry would cut straight through the center at x equals 0. So there is symmetry on either side. It should look exactly the same on either side. So x equals 0 would be your axis of symmetry if you need that. And then if you need your domain, that would be how far to the right and left it goes. It would be all real numbers because you have that arrow on each side, meaning you'd go infinitely to the right and infinitely to the left. And if you need your range, it bottoms out at 0, so it would be y values are greater than 0. But basically all we're doing is we're looking at our y value, seeing what's happening, making a pattern around that x value as we change it, and then squaring that pattern to get our y values. Let's try a different one. So this one also has a coefficient of 1. So right here, there is nothing in front, meaning that we could put a 1 here and it wouldn't do anything to the equation because multiplying by 1 doesn't do anything. So our pattern about the vertex table will still just be 2 columns, and it's actually going to be identical to the last one. We're going to have x and x squared. The difference here is we have a vertex, and these two numbers tell us how this graph has shifted on our coordinate plane. So if we see +2 - 8, we change the +2 to a -2, and we leave the -8 alone. So this you change for your x value, and this one you keep the same for your y value. So that's how you find your vertex. What's in the parentheses with your x, you change it to get your x value. What's in the back there, you keep it as your y value. Now, if we move left and right 1 square, we're going to square those numbers, and 1 squared and -1 squared is 1. So meaning I move left and right 1 square and I go up 1 square. If I move left or right from my vertex 2 squares, I'm going up 4 squares. If I move left or right 3 squares, I'm going up 9 squares. And just for good measure, we'll do 4 squares and I would be going up 16 squares. So I'm going to start at my vertex, which is -2, -8. From there, I'm going to go left and right 1, up 1. So left and right 1, up 1. We're following the same pattern we did in our last equation. Next, I'm going left and right 2 squares, up 4 squares. So again, from my vertex, I'm going to go right 2 squares, up 1, 2, 3, 4 squares. And left 2 squares, up 4 squares. So it should be a mirror image on either side. If you did this correctly, your y-intercept should be 0, -4. That's where it hits that y-axis right there. Next, I'll move left and right 3 squares, up 9 squares. And you should be just 1 above that x-axis. And we can move left and right 4 squares, up 16 squares from our vertex. And you'll be way up here for those last ones. So the only difference that happened with this graph compared to the last one is we shifted the whole graph 2 squares to the left and 8 squares down. So again, this number and this number give you the vertex, which shows you where you shift your graph on the coordinate plane. Let's try another one. This one, again, there's nothing here. So our coefficient is 1, meaning our pattern about the vertex table will only have 2 columns, which will be x and x squared. It's the exact same pattern as the other two we've done. So you'll go left and right 1, left and right 2, left and right 3, left and right 4. You'll go up 1, up 4, up 9, and up 16. Your vertex for this problem is the opposite of -3, which is +3, and then you leave the -5 alone. So 3, -5. So we're going to go 1, 2, 3 squares to the right and down 1, 2, 3, 4, 5 squares to get our vertex. That point right there is 3, -5. From that point, I'm going left and right 1 square, up 1 square. Same exact pattern. Left and right 2 squares, up 4 squares. Left and right 3 squares, up 9 squares. And left and right 4 squares, up 16 will be off the graph. So I'm going to stop there with my 9 squares. Again, you should have a U shape here that looks something like this. Those shapes are called a parabola. And if you want to know your axis of symmetry here, I'll draw it in on this one. The axis of symmetry cuts straight through the center of your parabola, through your vertex, at x = 3. So on either side of that x = 3, you should have symmetric points. So this point would be symmetric to this point. This one would be symmetric to this one. This one would be symmetric to this one. And this one's the vertex, which both sides share. So that right there is your axis of symmetry. Okay, let's keep going here. This one, you still have that coefficient of 1 right here. So your pattern about the vertex table will have 2 columns labeled x and x squared. So positive and -1, positive and -2, positive and -3, positive and -4 showing your left and right movement on the graph. If you square those numbers, you'll get 1, 4, 9, and 16, and that shows you your vertical movement on the graph. This number and this number show you how that graph shifts on your coordinate plane. So your vertex will be -4, -9, because the opposite of +4 is -4. You have to change the x value, and then -9 is your y value. It stays the same. So let's go from our origin back 1, 2, 3, 4, down 9 for our vertex. From our vertex, left and right 1, up 1, just like we've been doing. Left and right 2, up 4. Left and right 3, up 9. And that should be hitting your x-axis. You see you have two x-intercepts. One is at -1 and one is at -7 if you did it correctly. And then left and right 4, up 16. So if you did it correctly, your y-intercept should be at 0, 7. So this graph has shifted from our original x squared graph to the left 4 and down 9 squares. If you need it, your axis of symmetry will cut straight through the middle at x equals -4. So straight through the center of your graph, x equals -4. If you're having trouble seeing it, normally people are able to see like where the mirror image is, but if you can't figure out what the equation is, look at this. It crosses your x-axis at -4. So it's going to be x equals -4. That's how you figure out what that equation is. What axis it crosses at what number it crosses it at. All right, this one looks a little bit interesting because we don't have any number back here. So when we're missing a number in the back there, we are technically adding 0 to the equation because adding 0 to the equation doesn't do anything. So our coefficient here is still 1, meaning our pattern about the vertex table is still going to be x and x squared. So just 2 columns there. But our vertex in this case is going to be -4, 0. Because you change this, keep this the same. And so if you have nothing back there, the value is 0. So same table as we've been doing. You're going to square the movement on your x-axis to get your y movement or your vertical movement. And we're just going to start with our vertex at -4, 0. So from the center, you go back 4 squares, draw your vertex. From your vertex, go left and right 1, up 1. Left and right 2, up 4. And left and right 3, up 9. So your vertex here is right on the x-axis. So you might recall on our last view, we had 2 x-intercepts, right? It crosses our x-axis 2 times. But when the graph is touching your x-axis, you actually only have 1 x-intercept, and that x-intercept is your vertex because the vertex touches it at just a single point. So there may be circumstances where you have 1 x-intercept, 2 x-intercepts, or even 0 x-intercepts. All right, this one, we don't have a number in parentheses with our x. So the only number we have is our y value that's out in the back. So our coefficient is still 1 because multiplying by 1 doesn't do anything. So we'll have our plain x squared pattern about the vertex table. You're probably going to get tired of writing these because we have to do them for so many problems, but they're super helpful. So I know it may seem tedious, but it helps you follow your pattern very easily. Then our vertex, we're going to start by seeing if we have an x value. There's nothing there, so our x value is 0. And then our y value is the number in the back, which is -7. So our vertex is 0, -7. And from there, left and right 1, up 1. Left and right 2, up 4. Left and right 3, up 9. And left and right 4, up 16. I think we can fit that. Yes, we can, right there. And you can draw in your lines to make your parabola. All right. So that was all of the variations we could have when we have a coefficient of 1 on our quadratic. Now we are going into having an integer coefficient or a whole number coefficient. So in this case, we are going to have the integer coefficient of 2. So what's going to happen is our vertex isn't going to change. So our vertex, we have nothing in here with our x, nothing in the back. So our vertex is still going to be 0, 0. But our pattern around the vertex or the pattern about the vertex is going to change. Now, instead of y being equal to x squared, y will be equal to 2x squared. So we have to multiply our x squared by 2 to find the movement vertically after we move left and right on our x's. So we're still going to have left and right movement of 1 square with our x values, and we're still going to square that. So 1 squared is 1, and negative 1 squared is also 1. But now that we have this coefficient, we are going to multiply our x squared value by 2. So this value in the middle, the x squared value, which is 1, we're multiplying it by 2 to get 2 times x squared. So 1 times 2 is 2. We're going to do a couple more. So if we move left and right 2 squares on my x-axis or my left and right movement, to get my vertical movement, I'll square it, go up 4, but I not only need to square it, I also need to multiply it by 2. So it'll be 4 times 2, which is 8. We'll keep moving left and right 3 squares, square that, it'll be 9, and multiply that by 2, it will be 18. So now we have our vertical movement that is double our x squared value. The middle column is only used to get us to this third column. So when I finish with the third column, I actually scribble out my middle column so I don't get confused at all. Now I'm going to start at my vertex, which is 0, 0, and I'm going to use my first column, left and right 1 square, and my third column to get my vertical movement. So I'm going to move left and right 1 square, up 2 squares. Then I'll go left and right 2 squares, up 8 squares. And I can't fit left and right 3 squares, up 18 squares. It'll go off the graph. So essentially what we did by multiplying by an integer or a whole number is we stretched that graph out vertically, making it skinnier than our original quadratic function. So this is a skinny graph. It's been stretched vertically because we multiplied by a whole number coefficient. All right. What if we multiply by a fraction coefficient? So instead of a whole number, we're going to multiply by a fraction. Well, we have nothing in here with our x, nothing in the back. So our vertex is still at 0, 0. So we can go ahead and plot that point. Then we're going to make a pattern about the vertex table. You're going to have 3 columns because your coefficient is not 1. So you only have 2 columns when your coefficient is 1 because multiplying by 1 doesn't do anything. So here you're going to have the x squared column, and then our coefficient is 1/2. So we're going to have 1/2 x squared as our third column. So I'm going to go left and right 1 square. 1 squared is 1. And then I'm going to multiply that middle column by 1/2 to get my third column. So 1 times 1/2 is 1/2. Then I'm going to go left and right 2 squares. 2 and negative 2 squared is 4. And then I'm multiplying the 4 by 1/2 to get my third column. Half of 4 is going to give you 2. Then I'm going to move left and right 3 squares, right? Left and right 3 squares. And I'll get 9. 9 times 1/2 is 9/2. Some of you may be preferring to put 4.5 instead. That's totally fine if you want to use decimals instead. Same thing here. You can do 0.5 if that helps you. I just typically use fractions because I think they're easier, but let's keep going. We'll go left and right 4 squares. 4 squared is 16, and half of 16 is 8. So we went from multiplying by 2 in the last problem to multiplying by 1/2 in this problem because our coefficient changed from 2 to 1/2. Again, this center column no longer matters once you have that third column. And then we're going to graph with the information we have in the first column, our left and right movement, and the third column, which is our vertical movement. So it's not proper to graph half squares, but I'm going to do it just for the sake of showing it. So from my vertex, if I move left or right 1 square, I'm moving up half a square. So it would be right here and right here. From my vertex, if I move left or right 2 squares, I'm moving up 2 squares. From my vertex, if I move left and right 3 squares, I'm moving up 4.5 squares. And again, from my vertex, left and right 4 squares, up 8 squares. So you'll notice, in opposition to what happened when we multiplied by a whole number, when we multiply by a fraction, it actually squishes our parabola, making it wider or fatter. So when we did an integer, it stretched it vertically, making the graph look skinnier. And when we multiply by a fraction, it compresses it vertically, making the graph look wider. Okay? Now we have a negative coefficient. So this is a -1 times x squared, right? -1 times x squared. So our vertex here is going to be 0, 0 again. And then our pattern about the vertex table will have 3 columns, and it will be x, x squared, and then -x squared. So just like normal, you'll fill in your first 2 columns exactly the same as we've done from the very first problem. But then the third column, we're going to multiply all those numbers in the center column by -1. So it'll be -1, -4, -9, and -16. So we just made all of our x squareds negative because we're talking about a negative x squared movement as our y value. We'll start at 0, 0, move left and right 1 square. But this time, since it's negative, we're going to move down 1 square. So whenever you have a negative coefficient, your graph is going to open downward. So it's not going to look like a U, it's going to look like an upside down U because we're opening downward. So left and right 2 squares, down 4 squares. So negative means down. Left and right 3 squares, down 9 squares. And I can't fit that 16 on there. So what happened is our original graph opened upward when we had y equals x squared, but when we stick a negative in front of it as the coefficient, it forces our graph to open downward in the negative direction. So our axis of symmetry on this would still be x equals 0, right? It would still cut through the middle. And our domain on this, our left and right limits, would still be all real numbers or negative and positive infinity. But our range changes. So instead of going to positive infinity, this thing's facing down. So our range goes from 0 to negative infinity, right? So it goes all the way up to 0 and stops and goes down to negative infinity. Okay, now we're going to mix all this together. So I have a coefficient that is not 1, and I have a vertex that shifts my graph somewhere different on this coordinate plane. So I'm going to start by doing my vertex. So I'm going to say, what is the vertex of this equation, this quadratic function? I'm going to look what's inside of the parentheses with my x. It's -3. The opposite of -3 gives me my x value, which is +3. Then in the back here on its own is a -2. And that number in the back is always your y value. And you don't need to change the y value to get your vertex. Now, my coefficient is this number here. My coefficient here is 1/2. And you might remember when we're multiplying by a fraction, our quadratic is going to have a wider U shape. It's going to get compressed. It's going to look fatter. So we should have kind of a wide looking graph. So when we do our pattern about the vertex table, we will have 3 columns, which are x, x squared, and 1/2 x squared. So just like normal, fill this in with your left and right movement, your start to your up and down movement, and then your actual up and down movement, which is going to be 1/2 times that column in the middle. So 1 times 1/2 is 1/2. 4 times 1/2 is 2. 9 times 1/2 is 9/2, or you can say 4.5. And 16 times 1/2 is 8. Your center column no longer matters because we used it just to get to that third one. And we'll start at our vertex, which is 3, -2. Move left and right 1 square, up 1/2 a square. Left and right 2 squares, up 2 squares. So you have 2 x-intercepts here. It crosses our x-axis twice. The left and right 3 squares, up 4.5 squares. There's your y-intercept at 0, 2.5. And then left and right 4 squares, up 8 squares. And you will have a wide quadratic that has been moved on your coordinate plane to the right 2 and down, to the right 3 and down 2 squares. All right, we've got just a few more here. This one, your vertex is going to be +3, -9. So +3, -9. Then your pattern about the vertex table will have an x squared, and then your coefficient, which I just circled as 3x squared. So x squared, and 3x squared. So we'll move left and right 1 square from our vertex, 2 squares, 3 squares, 4 squares, and we'll square them so we can work toward our vertical movement here. We're going to multiply all of those numbers by 3. So 1 times 3 is 3. 4 times 3 is 12. 9 times 3 is 27. And 16 times 3 is 48. Obviously, the 27 and the 48 are going to go way off the graph, but this is just for the sake of showing you what it looks like. The center column no longer matters. We'll start at 3, -9. We'll go left and right 1 square, up 3 squares. Left and right 2 squares, up 12 squares. And left and right 3 squares, up 27 squares is going to go way off the graph. But you can see because we multiplied by an integer, which is just a whole number, we have a very, very, very skinny parabola. And the larger the whole number, the skinnier parabola would be. I think I might be off 1 square. Oh yeah, let me fix that. Excuse me. Sorry. Should be right here. Sorry, I got off 1 square there. Let me fix that. Anyway, but you're still going to have a skinny parabola as you get a bigger and bigger coefficient. Okay, wonderful. Let's keep going. We've got 2 more. So our vertex on this quadratic is the opposite of -1, which is +1, and then we'll keep the +9 as our y value. So we'll go 1, 9 as our vertex. You can see we have a negative coefficient, meaning our graph is going to open downward. So our pattern about the vertex table will have 3 columns. It will be x squared, and -x squared. So you'll go left and right 1, left and right 2, left and right 3, left and right 4. You'll square those numbers and then multiply all those numbers by the negative, which is your coefficient from your equation. Center column no longer matters. Go left and right 1 square from your vertex, and since it's negative, you're going to go down 1 square. Left and right 2 squares, down 4 squares. Left and right 3 squares, down 9 squares. You'll have 2 x-intercepts here. And left and right 4 squares, down 16 squares. There we go. All right, we have one more problem here. So this one is a -2. So you have a number and it's negative. And our vertex is going to be -1, 9. So the opposite of +1 is -1, +9 in the back. Our pattern about the vertex, again, you'll have 3 columns because you don't have a 1 as your coefficient. You'll fill in these columns just as you always do with your left and right movement. And then we will multiply that center column by -2 to get our movement vertically. So 1 times -2 is -2, 4 times -2 is -8, 9 times -2 is -18, and 16 times -2 is -32. So the center column, you can lose it. We'll go to -1, +9. From there, we'll go left and right 2 squares, 1 square, down 2 squares. Left and right 1 square, down 2 squares. Left and right 2 squares, down 8 squares. And then left and right 3 squares, down 18 squares. And you'll be way down here. All right, and that'll be it for graph.